Math, 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 math.
Oh, hey guys. So clearly it's becoming winter, so it's getting a little bit cold. So I'm taking out the real hipster hat today to stay warm. So today we're going to be looking at different types of functions. So grab your notebook, grab paper, pencil, glasses, flannel. Let's get started. All right, guys. So first thing we're going to look at is what a constant function is. So we're going to use an example. So let's say Cinema Guzzo is offering $6 movie tickets on Tuesday, regardless of the viewer's age. So it doesn't matter how old the person is, everybody goes to see a movie for $6. So if somebody's 10, it's $6. If they're 15, it's $6. If they're miraculously 200 years old, it's $6. For everybody, it's $6. All right. So it's really straightforward for us. So 0, we graph 0 on the x, 6 on the y. If we're doing someone's 10, 10 on the x, 6 on the y. 20, you see the point, it's 6 all the way across because it doesn't matter how old somebody is, it's $6. That is a constant function. It stays the same. Now, if we look at our rule y equals ax plus b, what we end up having is we're going to do the same thing that we've done before. So we do the change in y over the change in x, right? Well, in this case, there is no change. Y is not going up. It's the same. It's like the difference between 6 and 6 is nothing. So we have 0. But x is still going up. It's going up by 10 each time. So if we do 0 divided by 10, we get 0. So for us, there's nothing. So if we do that, we're basically done. Now we still have to look for b. So when x is 0, what's y? Well, if we look on our graph, when we have 0 on the x-axis, we have, boom, 6 on the y. So b is going to be equal to 6. So for us, a constant function, in this case, our rule is going to just be y is equal to 6 or a function of x is equal to 6. That's it. Constant functions always look like this. The y will always be the same number, and that's it. If it's the same number, you know you have a constant function. Okay, we're going to go on to the next one. So the next one we're looking at is a direct variation linear function. Okay, so we have our table, our x is going up by 1, and our y is going up by 40. Okay, so for this one, our rule is going to be y is equal to ax or a function of x is equal to ax. Basically, because we have 0 for the x and 0 for the y, we don't need b. Okay, it's not necessary. There's no point where the line is going through the y-axis. It's going through at the origin 0, 0. Okay, so for us, for a direct variation linear function, the line needs to go through the origin at 0, 0. So let's say we have a tattooer who charges $40 an hour to do a tattoo regardless of the size or color. Doesn't matter. Okay, so if he's worked for 0 hours, he's made $0. If he's worked for 1 hour, he's made $40. 2 hours, $80. Same thing, right? So we start graphing it. So 0, 0, we graph 0, 0. 140, we graph 140. And we just keep doing that until we have our line. Now, we still need to come up with our rule, so we're still going to do the same thing. Change in y over the change in x. So if we look at our y, well, each time it's going up by 40. And if we look at our x, each time it's going up by 1. So a will be equal to 40 divided by 1. And if we do that, we end up with a is equal to 40. So for our rule, we have y is equal to 40x. Now we're still going to do plus b just to make sure that you guys are okay with it. So for b, we know that when x is 0, we need to know what is y equal to. Well, in this case, when x is 0, y is 0. It's going through, bam, at the origin, which means there is no plus b. So our rule is just going to be simply y is equal to 40x or a function of x is equal to 40x. That's it. So a direct function, you're always going to have 0, 0 for your x and y, and the line is going to go through the origin. All right? Now we have to do a partial linear function. So if we look at our table, we have our graph. So in this case, the rule that we'll use is going to be y is equal to ax plus b or a function of x is equal to ax plus b. So this is when it's not a direct variation, but the rate of change is still constant. So it's still going up by the same amount. Okay? So let's say it costs $40 to rent a monster truck for the day, and $20 for every mile that you drive. Okay? Well, if you haven't driven anywhere, so if you've gone 0 miles, you still rented the truck, so it's going to cost you 40 bucks. And then it's $20 for every mile. So if you drive 1 mile, it's going to be $60. 2 miles, 80. So we do the same thing. Okay, so 0, 40, we graph 0 on our x and 40 on our y. And then we just plot our points, do our line. We've now graphed the line. But now we still need to come up with the rule. So what we do, same thing. It doesn't change for us right now. Change in y over the change in x. So we look, well, our y-axis is going up by 40, our x is going up by 1, sorry, it's going up by 20, and we're going up by 1. So we're just going to go 20 divided by 1, that gives us 20. So we already have our a. Right now we know y is equal to 20x. Now what we need to do though is figure out what the b is. So when x is 0, what is y? Well, if we look at our graph, the line passes through y at 40. So for us, our rule is just going to be y is equal to 20x plus 40. And that's it. Those are the 3 functions that we're looking at. Constant, direct, and partial. And the way you'll remember for the partial is if you look, when x is 0, y is a number. In this case, we have 40. Okay? So I hope this video is helpful for you guys. And that's pretty much it. I'm going to take this hat off because even though fall is hit, it's way too hot under here. I'll see you guys next time.